Welcome in 7th grade. In this video, we're going to look at Eureka Workbook Module 1, Lesson 1, and Experience and Relationships as Measuring Rate. All right, and when you open up your workbook, the first thing you're going to see in this lesson is a couple of key terms from 6th grade. We're going to review those in just a second because in this opening exercise, there was a little experiment that Eureka wants us to do, but given the situation with the Backstreet Boys tour, we are going to pretend as if we did this experiment. Okay, so we're not all going to touch the papers and pass them all out and then touch them and bring them back again. We're just going to avoid that kind of cross-contamination, avoid anybody getting tickets for the Backstreet Boys. All right, so in all of these experiments that we're going to do, in each one of these little trials we're going to do, and you're going to, whether you're at home or with me in class, you're going to copy this down as I write it. We're going to be passing out 24 papers each time. All right, so for each one of these experiments, we passed out 24 pieces of paper. All right, so in the first trial, I pulled the wool over your eyes. I didn't let y'all know, so we did it a little bit slower. It took us 12 seconds. And wow, guys, yeah, thank y'all for participating. Everybody touched the papers and handed them back in. We did great with that. Took us 12 seconds in the first trial. Okay, but now y'all are being challenged. Let's see how about it took y'all 11 seconds in the second. Great. And then the third trial, guess what? It took us 10 seconds. And in the last trial, it took us 8 seconds. All right, fantastic. Fantastic. Thank you for your participation in that little experiment. All right, so come back up to the top of the page here, and we're going to look at these key terms from 6th grade. So we definitely talked about these last year, but these are just a review. You are going to need to get some notes for this, but I'm going to condense these for you. You don't need to write these down right now. We're just going to review this before we start the lesson. All right, so a ratio is an ordered pair of numbers which are both not zero. A ratio is denoted as AB. So for example, a ratio, if it were numbers, right, these are just variables. If they were numbers, it would be like 1 to 2. And maybe some of you have seen things like this, like odds for sporting events like that. They have a 1 in 3 chance of winning or something, 1 to 2, right? So a ratio is denoted as AB with the little colon in between a number and another number. Usually it can be variables as well. It's denoted as A colon B to indicate the order of the numbers. And again, and we talked about this last year in class. The order of the denotation matters, right? A is the first number. B is the second number. All right. Two ratios, A, B, and C, D, are equivalent ratios if they are non-zero numbers, if there is a non-zero number, C, that can, such that C equals C times A and D equals C times B. For example, two ratios are equivalent if they both have values that are equal. Fantastic. So, for example, 1 to 2 is the same as 1 to 2. Fantastic. Now, there was these words. I'm definitely going to rephrase this for your notes. But essentially, let's look at just this little formula right here, right? So, let's say we have AB, right? And let's say we multiply both parts by a number, okay? Maybe let's instead, okay, let's forget about the variables. Let's go back to our number example right here. So we have 1 to 2. Let's say we multiply both of these numbers by the same number, C, okay? Remember, C is just some number. It doesn't matter what number it is. But as long as we multiply both parts by the same number, let's say 3. Let's multiply both of these parts by 3. So then we have 1 times 3 is 3. 2 times 3 is 6. So 1 to 2 is equivalent to a ratio of 3 to 6, right? And it's similar to the way fractions work. They're not exactly the same, but in this way, equivalent ratios are similar to equivalent fractions, right? If you multiply both parts by the same number, they will become equivalent. All right, and this will become apparent as we go throughout the lesson. A ratio is a relationship between two types of quantities, such as 5 miles per 2 hours, can be described as a rate, quantity per hour, right? So this comes to the next part right here. The numerical part of the rate is called a unit rate, and it is simply the value of a ratio. In the case it's 2.5. This means that in 1 hour the car travels 2.5 miles. Okay, so those are just the single unit rate, right? So in this example, they said 5 miles per 2 hours. So if I traveled 5 miles in 2 hours, that would be the same as saying I traveled 2.5 miles in 1 hour. Or at least those ratios are similar, right? And so the unit value here, if we're looking at this as a fraction, if 2.5 over 1, well, it's just 2.5, right? 2.5 miles per hour. So a unit rate is the amount that can be done within 1 unit, in this case, miles per hour. All right, so let's come back down to our experiment, and let's use this term. Let's apply these terms that we just learned about, okay? So we did our experiments, right? We passed out some papers over here and took us some times in each one of the trials. Now we want to write in this column right here, we're going to write the ratio of number of papers passed to time. Okay, so ratios, again, it's important, the number that comes first in the sentence here. So since this sentence is saying ratio of number of papers first, the number of papers is going to be the first part of the ratio. Hope that makes sense. So since in this statement we're asking for the ratio of numbers of papers first, numbers of papers is going to be our first number in the ratio, right? So numbers of papers each time it was 24. You can actually just kind of come down here because we know that our first number in each one of these is going to be 24, right? All right, and our ratio in this first one it's a ratio of number of papers passed to time. So in time, it took us 12 seconds. So our second number in the ratio is going to be 12. So 24 to 12, right? And in the second one, you just go down, same thing, 24 to 11. Time is our second value here. 24 to 10, 24 to 8. Again, whether you're in class or following along at home, you're copying all this down. Great, fantastic. So this is the ratio of number of papers passed to time, right? The number of papers passed in the number of seconds. All right, so next we're going to move on to our rate. Our rate and unit rate, which hopefully I will make clear the distinction between these two throughout the lesson, right? So our rate. So I actually want to start by finding the unit rate. Because once we find the unit rate, the rate is essentially just a description of the unit rate. So we talked about the unit rate up here a little bit, but how do we actually calculate it? Well, in this case, our units are seconds. Our units are the time, right? And we're comparing that to numbers of paper we pass out in a certain amount of time. So we want to get our units of seconds down to 1. So how are we going to do that? Well, it's actually a lot simpler when you think about it like this. Okay, we're going to take the number of papers that were passed out and divide it by the number of seconds that it took. So in this first example, we have 24 papers passed out in 12 seconds. So all we need to do is divide 24 by 12 to get us the unit rate, in this case, which is 2. And your unit rate is really just that number, okay? So In this case, we had a unit rate of 2, right? But what is that actually describing? That is the rate right here, right? What is 2 actually saying? Well, in this case, again, we're describing 2 papers per second. And we could say per 1 second, but that's sort of redundant, right? Per second is implied that it's just 1 second that we're taking to do that. So 2 papers per second in this first example. Now, in this case, it was pretty simple to divide 24 by 12 because it goes straight into it, right? But what about when we come down here? In this case, we shaved a second off of our time. Oh boy. So now our unit rate would be 24 over 11, right? So how can we calculate that? Well, if you know your long division, we can do this by hand. We come down here. How many times does 24 go into 11? I know it goes into there twice. 22, that means I have a remainder of 2. Add a 0. How many times does 11 go into 20? It goes into there just once. Yes, just once. And then subtract, get to 9, means 90. How many times does 11 go into 90? A bunch of times, probably like 8 times. And we get back to 88, which means we're back to 2. Okay, so then I know that that's going to be repeating forever and ever. So in this case, our unit rate is 2.18, like that. Now, in the Eureka, it tells me to round it up to the nearest tenth. So if we use the calculator to do this, it'd be just like this. So 24 divided by 11. And realistically, we just kind of want to round up to the nearest tenth here. Either one of those is fine. I actually did the work, so I'm going to keep this up right here, okay? So we have 2.18 repeating, right? That's our unit rate. So that is to say that our rate is 2.18 repeating papers per second. Now, if we did the rounding here, if instead I wanted to say 2.2, which I'll do, 2.2, because this is not an exact measurement, this is not exact unit rate, this is an approximation, we would say approximately. Whenever we round, we're going to say approximately, since it's not precisely. All right, so these last two I want you to try on your own. Find the unit rate, write the rate, and then we'll come back and we'll discuss what you found. I'm going to give you all about 90 seconds to do. Go ahead, y'all. Go ahead. Great work. Y'all work so diligently. Thank you so much. Okay, so we'll have 24 over 10 here. This will divide perfectly into a decimal, 2.4. So 2.4 papers per second. I'm going to put papers per second, PPS, shorthand that a little bit. And then right here, we'll have 24 over 8, which is exactly 3. So exactly 3 papers per second. We got a lot faster, right? Y'all accepted the challenge and we got faster each time, right? Fantastic. So these would be the final answers right here. Great work. We're going to move down now. And whether you're at home or in class with me, if you're in class with me, we can do this exercise together. So we're going to take a poll and see how many number of boys are in the class, number of girls are in the class, and we're going to write the ratio between that. So if you're in class with me, you can skip over this part. But if you're not in class with me, let's make up some numbers real quick. So in class 1, the number of boys was what? I don't know. This is small school, right? So let's say there's 7 boys, and I don't know. Let's say that there are 12 girls in the class, right? So the ratio, and again, this is where the order matters, right? So here we're asked for a ratio of boys to girls. So we want the number of boys to come first. Number of boys to the number of girls, right? So 7/12 would be, let me come up with another example in class too, maybe that I can show y'all how to simplify. So let's come back up here real quick and look at this first example. So we can simplify this ratio 24/12 into 2 to 1. Those are equivalent ratios. And the same thing down here, we could translate this to 3 to 1. All right, so let's come back down to our boys and girls club. And let's just say that there are 8 boys in a class and let's say 12 girls again, right? So ratio of boys to girls would again be 8 to 12. However, both 8 and 12 have a common factor of 4. We can divide 8 and 12 by 4. We divide 8 by 4, we get 2. 12, we get 3. That is just to say that those are equivalent ratios, right? And in this last part, it's going to ask you to add these up together, and that's what I want you to do on your own. Add them up. Let's get the whole 7th grade, this hypothetical 7th grade class, number of boys, number of girls, and you come up with a ratio. All right? We're going to come down now and we're going to take a look at this next question that they asked us here in the workbook. It asks us to create a pair of equivalent ratios by comparison of quantities discussed in this example. Well, we could do that, and if you're in class with me, we may do that. But if you're not in class with me, let's keep discussing equivalent ratios, right? So let's just throw some examples out here. So let's say we have a ratio of 3 to 2. I like my numbers small. And we want to make some equivalent ratios from that. Well, like we mentioned at the top of the lesson, if you multiply both parts by the same number, you're going to get an equivalent ratio. So let's just say we multiply both of these by, I don't know, let's say 5. Multiply both parts by 5. So 3 times 5 is 15, 2 times 5 is 10. So that is to say, 15 to 10 is equivalent to 3 to 2. Yes? So here's what I want you to do right now at home. Let's give me, I'm going to give you a ratio, let's say 2 to 5. All right, and I want you to give me 3 equivalent ratios based on that. Great, those all look like great examples. Okay, so as long as you multiply both parts by the same number, you're going to get an equivalent ratio. So for example, if we multiply both by 2, we'll have 4 to 10. If we multiply them both by 3, 6 to 15. Keep going by 4, that would be 8 to 20. So those are all equivalent ratios. All right, so I mentioned this when we did 24 to 12, and let's use that as an example, right? 24 to 12. In this case, we can create an equivalent ratio of this ratio without multiplying, right? Instead, we can divide, right? So we can multiply or divide these by any numbers, and as long as we do it by the same number, they stay equivalent, right? So if we divide 24 by 12 and we divide 12 by 12, we maintain the equivalency of the ratio. So 2 to 1 is an example. Another one would be 4 to 2, etc., 6 to 3. So those would all also be equivalent ratios. Because remember, when we're dividing here, we divided by 12, but really when we think about it, what we did was multiply 24 by 1/12, which is the same as dividing by 12. So really we're still multiplying both parts of these ratios by the same number. They just happen to be fractions this time. Fantastic. Okay. All right. So if you're in class with me, maybe we skipped over those 2 parts. But if you're not in class with me, or whether you're in class with me or not, I want you to read exercise 1 and you're going to find the best value. Okay, this is definitely a real world situation that maybe some of your parents had to go through recently coming back to school, right? So Value Mart is advertising back to school sale on pencils. Great. It boy, as a math teacher, I don't care about Value Mart. I just don't care about them. So, but they're selling a pack of 30 a pack of 30 pencils for $7.99, whereas a 12 pack costs $4.77. Which is the better buy? How do you know? So I want you to take some time, think about how you can come up with which one of these is a better purchase. Okay, I'll give you about 2 or 3 minutes to work independently. You're working already. You should be. Go ahead. You're reading this. Great. All right. So just like we looked at with the last example, in this example, we're going to just be trying to find unit rates. Okay. So we want to find, in this case, we're talking about pencils. So we're trying to find the unit rate cost per pencil, right? So in this pack, we have 30 pencils for $7.97, right? So how can we find out the unit cost per pencil, right? Well, let's take the total cost, $7.97, and let's divide that by the number of pencils we get, right? So this is $7.90 per 30 pencils. So the way we calculate the unit price here is dividing 7.97 by 30, okay? And I am going to go ahead and I am not going to ask you to do long division. You can get out your calculator as well, and let's do this together. So let's divide 7.97 divided by 30. It's important to know how to do long division, okay? It's important. In this case, what we will have is, and we're not going to write equals, right? Because look at our answer here. That's not exactly a whole rounded number, right? It looks like that's a repeating 6 forever right there, right? So we're going to write approximately, and at the top we have our price, 26, and we're actually talking about money here, right? So when we're talking about money, you go behind the decimal. This is like every 10 cents. This would be every single cent. We don't have any hay pennies or anything anymore. We're about to get rid of the penny. So let's round to just the nearest penny, right? So 2.56. So we're going to round that to, let's say we'll round it up, right? If it's 5 or larger, we round up. If the next decimal behind it is 5 or larger, that's what I was always taught. Let me know if you were taught something different, okay? But in this case, I'm going to write approximately, and if I didn't mention this before, these little squiggly lines, we talked about this last year, these little squiggly lines right here, that means it's close, okay? Not exactly, this is approximately, right? Approximately, not exactly equal, but it's close, right? So approximately equal to 27 cents, or $2.7, we could say, $2.7, which we know is 27 cents per one pencil. So in this pack, our unit price is 27 cents. All right, so what is that actually? What are we saying here? 27 cents per one pencil. That means each pencil costs 27 cents. Yeah? You with me? Now, we have to buy it in the 30 pack, but every pencil, we're going to assume that these pencils are of the same length, same value, inherently has a pencil. And so each pencil is 27 cents in this pack. All right, so now let's calculate the 12 pack, right? All right, so in this example, hello, we good? Okay, we're back. Okay, in this example, we have a 12 pack of pencils for $4.77. So we have $4.77 per 12 pencils. All right, great. So now we're going to calculate just like we did before. We're going to divide the total cost, 4.77, divided by 12 pencils. And we get a number that looks like this. This is actually a fine number, a complete number. It's not repeating or anything. It's not a repeating decimal. It terminates. But again, we're dealing with money here, right? So we can only have two decimals behind, 2 places behind the decimal. That's how many cents it is, right? So again, we're going to write approximately again. So we have approximately 0.3. Well, actually, we're going to round up, right? So we get approximately 3. Okay, so if I round this up, this would be approximately 40 cents. I'm going to round up there to approximately 40 cents. Or we could say $0.44, right? Which is 40 cents per one pencil. So the unit price is 40 cents, right? All right, so you should have come up with something like this for your unit price. If you rounded down on either of these, that's fine. So if you put 26.39, you're not off. Or if you put the exact number, that'll work too. Okay. Now the question is, which is a better buy? How do you know? So, which one is a better buy? Which one is cheaper per pencil? If you selected the 30 pack, then you are correct because 27 cents is less than 40 cents. So these pencils is cheaper, right? Now, obviously, when you're buying stuff, there's going to be some preferences. You said, like they said, these are brand name. So maybe you like that brand better. There's always a cost benefit to these things in real life, but the cheaper ones are the ones that come in the bigger pack. And actually, that's actually pretty typical of real life as well. Okay, so we're going to go ahead and move forward here. Great, we're down to lesson summary. And unit rate is definitely the key vocabulary term I want to take away from this, right? It's often a useful means for comparing ratios, just like we did in this example right here, where we compared the prices, right? It's very handy. A unit rate makes it. That's why a lot of car companies, when they sell cars, they'll tell you the miles per gallon. What's going on up in? They'll tell you the miles per gallon. Hello? They'll tell you the miles per gallon. That's a unit rate, right? And it's something everybody understands. You get this many miles per this many gallons of a car. And when you're comparing cars, that's a useful measurement to know about. Okay, a lot of people care about your MPG. Okay, so it's useful for comparing ratios, comparing real life situations, and their associated rates when measured in different units. Right, very good. The unit rate allows us to compare varying sizes of quantities by examining the number of units of one quantity per 1 unit of the second quantity. Right, so we're always comparing two different quantities, right? In cars, we're comparing miles per gallons. In this example, in this example up here, we were comparing pencils per dollar, right, or dollar per pencil. Yeah, and in the class example, we were comparing boys to girls, the number of boys to girls, right? This value of the ratio is the unit rate, right? So the unit rate is your number value of that ratio. Okay, so when we compare boys to girls, for example, 8 to 12, the unit rate, oh, that wouldn't have been great. When we were passing out papers, We did 24 to 12, and the unit rate was 2. Great, fantastic. So from here, you're going to work the exit ticket and problem set. Remember your rules for your rubric for answering constructive response questions. Okay, so find each rate and unit rate. Great. Now remember, the rate is your description of it, right? Your unit rate is the number, but you also need to have the rate. So you need to have the description. So 420 miles in 7 hours. You find the unit rate by dividing the number of miles per hour, and then your rate is just the description of that. So I'll go ahead and I'll do this one just as an example. So I'm giving you A real quick, okay? So in this example, our unit rate would be 420 over 7, which would be a number. Well, I think I can do that. That's like 6. Let me just check. Not 6, but 60. Yeah, 60 miles per hour probably, right? 420 divided by 7. I'm just going to double check. Yeah, definitely. So in this case, our unit rate is 60 over 1, or just 60. 60 miles per hour, right? And this is your unit rate. This is the description. You can write this all the way out if you'd like. I honestly, if you want to just write the rate with the unit rate in it, that's fine. I don't need it separated per se. Fantastic. Okay, so again, for questions 2 through 5, remember how we respond to constructive response problems. Remember your rubric. Thank y'all for joining me. See y'all tomorrow, maybe. I don't know.